Hello everybody, this lesson is a stoichiometry. First I will give you a brief definition of stoichiometry and then we will solve different problems to find the ways that how we can solve these problems. A stoichiometry is the quantitative study of reactants and products in a chemical reaction. Suppose, for example, 60 grams of hydrogen reacts completely with nitrogen to form ammonia. How many grams of ammonia will be formed? To solve such a problems in chemistry, we need to follow 4 steps. First, we need a balanced equation. And then we need to convert the grams to moles, use the mole ratio from the balanced equation, and then convert the amount to grams if needed. Maybe it seems that this process is a bit complicated and many, but I will tell you how we can solve these problems easily only in one line. For this problem, first I need to write the equation and then balance it, as I taught you in previous lesson. The reaction of nitrogen and hydrogen, which leads to the formation of ammonia. First, I will write all the atoms of the left side and right side, both, and then I will try to balance them, nitrogen and hydrogen. Okay, 2 nitrogen in the left and 1 in the right, 2 hydrogen and 3. I will start first from nitrogen and I will add number 2 here. Now I have 6 hydrogen at the left, while 2 on the right, 6 hydrogen on the right here in the products, and 2 in the left. So by addition of number 3 here, I have balanced all these items. Now in one line, I will solve this problem. This question asked about how many grams of ammonia. So x gram of ammonia that we need to find it, which is equal to 60 gram of hydrogen that we know we have it. Well, I know that 1 mole hydrogen, molecular, actually 2.0160 gram of the hydrogen molecular mass, atomic molecular mass of the hydrogen, multiply. So in this step, now I have converted the grams to mole. Then now I need to find the molar ratios from the balanced equation. From the balanced equation, I know that the 3 mole of hydrogen here leads to the production of ammonia. How much? 2 mole ammonia. And then in this step again, I will need to convert mole to grams because this problem asked about grams of ammonia. And I know 1 mole ammonia, the molar mass of ammonia is 17.03 gram of ammonia. The final result is 90.1 gram of ammonia. For the next question, methanol burns in air to produce carbon dioxide and water. If 209 grams of methanol are used up in a combustion process, what is the mass of water produced? The first thing that we have to do is writing the equation. Methanol, when it burns in oxygen, produces carbon dioxide plus water. I leave spaces here in order to add the numbers to balance the equation. Okay, in the left side, in the reactants, we have carbon, hydrogen, oxygen, and in the product, the same. 1 carbon here, 1 carbon here, hydrogen, we have 4 on the left, and we have 2 on the right, oxygen 2, 3. Okay, first I will balance hydrogen by adding number 2 here. Now we have 4 hydrogen in the products and 4 hydrogen in the reactants, but the number of the oxygen are not balanced. So now we have 4 oxygen here. I will write here 4. And how many oxygen here? We have 3, not 2 from the beginning when I did it wrong, I'm sorry. 3, but still they are not balanced. Nothing has been changed. So how to balance them? If I add here ratio 3/2, now we have 4 oxygen here and 4 oxygen here. But since all the numbers should be a whole number, I will multiply all this equation by 2. So the balanced equation is 2 methanol when they burn with 3 molecule of oxygen, they will produce 2 molecule of carbon dioxide plus 4 molecules of water. The next step is write all these conversions that I told you in one line. So we need to find the mass of water. I will write x gram of water. I need to find it, while I have 209 gram of methanol. Now I need to change it to mole. Okay, 1 mole methanol, its molar mass is 32.04 gram of methanol. In the next ratio, I need to write the molar ratios from the balanced equation. I know that 2 mole of methanol produces of 4 mole water. And now I need to convert mole of water to its gram. And I know from its molar mass, 1 mole of water has 80.02 gram of water. Similar units goes with each other. Mole, methanol, grams of methanol with each other. And the only unit is gram of water, which is remain. The final result is 235.1 gram of water. The last example seems a bit long. The food we eat is degraded or broken down in our bodies to provide energy for growth and function. A general overall equation for this very complex process represents the degradation of glucose to carbon dioxide and water. Great. If 856 gram of glucose is consumed, I will write 856 gram of glucose consumed by a person over a certain period, what is the mass of carbon dioxide? Okay, I will start solving this problem in a new sheet. As I mentioned you, first we need to write the equation. Glucose, the molecular formula that we have is C6H12O6. When it reacts with oxygen, it produces carbon dioxide plus water. So I need to balance. First, it is clear that here we have 6 carbon and here we have 1. So it's easy while I have a number 6 here. Okay, now the number of oxygen and hydrogen should be balanced. Well, hydrogen we have 12 here while we have 2 here. Okay, so if we add 6 again here, I have balanced hydrogen either. The only item is remained is oxygen. That here we have 8 oxygen now, but here we have 18. So 12 oxygen is remain. So if I add a number 6 here, so I will generate the same 12 oxygen. So here again we have 18 oxygen and here 18 oxygen. So now I have the balanced equation. The only thing is that I should write all these conversions in one line. So we need to find the gram of carbon dioxide while I have 856 gram of glucose. Better that show glucose like that here. Better to show glucose right GLU multiply by 1 mole glucose is 180.60 gram of glucose. And then after this conversion, conversion of gram to mole, I need to use the balanced equation to find the mole ratio. I know that 1 mole glucose produces 6 mole carbon dioxide. And again, I know 1 mole carbon dioxide has the molar mass of 44.01 gram of carbon dioxide. Now, they go and the final result is 1.25 multiplied by 10 to gram of carbon dioxide. Same thing that we want. Now I have a practice for you. Okay, since it was a general question about the alkali metals, they specified it for lithium. So consider this equation only for lithium. And then you need to balance this equation first and then use the same simple one line. I named this way in one simple line calculation to find the amount of lithium to produce 9.89 gram of hydrogen. Follow me in the next lesson. I will solve this practice for you, and I want to talk about limiting reagents, which are very, very important, but I will solve all the practice for you in an easy and simple way. See you